Okay, we are in section 1.4. Let f be a function on a open interval, AB, and scan the graph of f from left to right. If f is rising from x equals a to x equals b, then f is increasing on AB, and if f is falling from x equal a to x equal b, then f is decreasing on AB. Okay, so as an example, suppose that we have f of x equal x cubed minus 3x. Where is the function increasing? Where is it decreasing? By the way, it is constant if it is neither increasing or decreasing. So if the value of f is 0 for a particular value, like here at 1 and negative 1, f of x is going to be 0. Now, I've drawn this curve, f of x equal x cubed minus 3x, and at x equals and anything less than negative 1 means that the slope is increasing. And if I draw a tangent line anywhere, the slope of the line is some positive number. Okay, and again, a positive slope means that you're slanted this direction, and a negative slope means that you're slanted in the negative direction. Okay, so anywhere that is less than negative 1 and bigger than 1, it looks like, if I scan the graph from left to right, I'm going to be increasing on that part of the graph. Now, it's all about x, wherever we're increasing or decreasing. Some people mess this up, which is a shame. Okay, and so it's all about x. Okay, keep that in mind. You're increasing on the interval negative infinity to 1. Here's 1, 2. Negative 1, 2. And here's 1, negative 2. Okay, so I'm increasing to negative 1 and also increasing from 1 to infinity. I'm decreasing on the middle part of this graph, that is from negative 1 to 1. Okay? So if I begin with an expression here, such as the constant function has the equation f of x equals b, and b is any number. Okay, so the domain is all real numbers. The range is the set of all y's such that y is equal to b. Because the y and f of x mean the same thing. Y and b would be the same. Okay. Now, on my graph, b looks like it's about maybe 2.75, something like that. Okay. The intercepts are 0b. Wherever I draw this line is going to be the one and only intercept. Except if I draw the line on f of x equals 0. Y equals 0 would be a line right on the x-axis, and y equals 0 means that I've got the points 0, 0, 0, 1, 0, 2, 0, negative 1, 0, negative 2, 0, 1 half. Okay, so what if b is 0? If b is 0, then you're going to have infinitely many values that are in the range. Okay. Otherwise, if b is any other number not 0, okay, you're only going to have one intercept then. Are we increasing or decreasing? Well, none. F is constant on the interval negative infinity to infinity. In other words, if anywhere that I draw this line is going to be a horizontal line, and a horizontal line is neither increasing nor decreasing, so we're constant on that part of the graph. Okay, here's one. The identity function. The equation there is f of x equals x, or y equals x, same thing. Y equal x is a line slanted at a 45-degree angle in quadrants 1 and quadrants 3. The domain is any real numbers. The range is also any real numbers. The intercepts are 1, 0, 0. Increasing or decreasing, you're increasing everywhere. This is a line, specifically a line slanted at a 45-degree angle, and you're increasing then on the entire number line. Okay. The next one is the square function. F of x equal x squared is the equation, and the domain is all real numbers. Okay, I can square any number I want, is the way to look at it. The range is all positive numbers. 0 is fine also. So if y is 0, then x is 0. 0, 0 is on the graph. If y is 1, x is -1 or +1, and so y. In other words, any number that I square is always going to be a positive, a non-negative number, I should say. So that's why the range is all non-negative numbers. Now, with the range, if I take the pencil and I draw a horizontal line anywhere, then anywhere that is 0 or bigger would put me in the range of the function. So 0 to infinity. I can draw a vertical line anywhere. Okay, the curve goes outward in both directions. The intercepts are at 0, 0. You're increasing on 0 to infinity because from 0 to infinity, if I draw a tangent line there, it's going to have a positive slope. And I'm decreasing on the interval negative infinity to 0. If in other words, the graph is falling from negative infinity to 0. Okay, so at 0, 0, and by the way, your open intervals are not including 0. Okay, at 0, 0, you're constant on the graph. Okay, so at that single point, if you draw a tangent line, that would be a horizontal line. Okay, the next one is the cube function. The cube function, y equal x squared, or f of x equal x squared, same thing. The domain is all real numbers. The range is all real numbers. You cover the x-axis and the y-axis, both of those. The intercepts, the one and only, is 0, 0, right here. You're increasing everywhere on the interval, negative infinity to infinity. So even at 0, 0, you have a vertical tangent. But if you look to the left and to the right of 0, 0, the number on the left, the y value, and the y value on the right are one is negative and one's positive. So you're still increasing on that part of the graph. Okay. Let's stop right there.